In many of our projects and analyses, we want to compare one set to another. For instance, what did our supplier measure? What did we measure? Situation before, situation after. Only two populations. Then you will often use a t-test to significantly test if they are different, if you had an effect. So let's check how to perform a t-test in Excel. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's topic is the t-test in Excel. But before we go into Excel, let's discuss a little bit about what the t-test is. Not too deep, but just enough so that we know what we can use in Excel to do something else than purely the t-test function. Because, spoiler, that is the easiest way to do it. Excel has a built-in function, but that built-in function has a couple of limitations that you might need to circumvent from time to time. Because what a t-test does is to separate between two groups, so two populations, and check if there is a significant difference. And a significant difference means that there is a different mean, an average, that's the top part of the formula, when you compare it to how much spread is there in this whole sample population to begin with. And that's the bottom part. This, by the way, is the standard error. So how do we get to this significant or not? In a t-test, that's where we compare this t-value, which is just a calculation within the test. It's not your final result yet. And we check how this is in the t-distribution. You will probably know a normal distribution. And if you have a t-distribution with a very high sample size, you get again a normal distribution. But what they found out roughly 100 years ago, already in practice, is that when you have a lower sample size, and under 30, we are really speaking already of a lower sample size. But really, if you are dealing with 8 or so, go for a t-test instead of a normal ANOVA. And that is because you need to take into account longer tails. And to take this into effect, you have a student distribution that you check for how many samples am I putting in. And this is also a normal function already in Excel, so you do not need to look up this table. The data is already in the program, and it will give you, if you want a distribution, a t-distribution for sample size 8, it will tell you what would you like as a significance point, 0.05, our usual 5%, and then it will say 2.5% there, 2.5% there. It's a two-tailed significance, and you get 2.36, I believe. And then it checks, is this t-value higher than 2.36? That means we're in the last 2.5%. It's not very likely that these populations are the same, so we conclude a significant difference. Is it lower? Then we are still within 97.5%, but that means we cannot say that there is a significant difference at the 5% level. So that's basically what the formula does. Important to know for when we plot it into Excel is that this is all already in Excel. You can just get these numbers without having to refer to any tables. It does not depend on your data. It only depends on how many samples do we put in a sample size. To get the t-value, we need a little bit more. We need to have averages of ranges, but the most tricky part and the reason why you might use different ways in Excel is that we need the standard deviation of our sample to get to the standard error. And that's the part we'll be looking at within the program. So here we've got some sample data. This is just completely fictional, but I made like a goods entry where we have bags that we receive. They have a weight on their order and documents. We check them again, so we weigh them again at our factory, and there is a difference from time to time. We have 3 suppliers, and we just want to know how is it going in our goods inventory, in our goods received portion with the weight of these orders. And one of the first things we then can do is just use our t-test. And the basic way to do a t-test is actually to just use the t-test formula, which is a formula that uses 2 arrays, and then you have to tell it, is this a 1 or a 2-tailed thing? So do we expect that the weight that we measure will always be lower for some reason, then we do a one-tailed difference seeker. But usually we just think that there will be an equal chance, basically, that it's higher or lower, and then we take a two-tailed significance. And then you can fill in a type, and the type can be either a paired t-test, a single versus population, or a two-population t-test. So here we have a paired t-test because we actually have each order that the supplier told us one thing, we measure our own value. Now, what do we see? It is lower than 0.05. So here we have a significant difference between what the supplier sells us and what we get from them. That's not a good thing. So let's check a bit deeper. The other data that I put here is not directly needed for the t-test itself, but if you use it in a practical setting, you will always also want to know this information. So what is the mean that they sent to us? What is the mean of what we measured? And what is the difference? And basically, it's a very good difference for us because when we measure it, we get a higher weight than what the supplier sells us. So not really a problem, right? Now the thing is, we have 3 suppliers, and there might be a difference between those. So we have to check what each of those is doing. And I did it here, and before we go into how I did it, we indeed see supplier A, well, very small difference, but not significant. So we should just say there is no difference. Supplier B, very significant positive difference. Supplier C, well, basically absolutely the same. Doesn't mean that everything is immediately rosy, but we do see that this conclusion from the overall t-test really has to do with supplier B. Something is not aligned with that supplier. Now, how did I do it here? Also with these same t-tests, but here what I did is I manually ordered them on supplier by alphabet, and then also selected those rows manually. And this, of course, is not a very sustainable way if you want to add some data later on. So this way to do the t-test is very easy to do in Excel, but if you have a changing data set, this will not do. So we need a way to get that working. And in fact, there is a very nice way to do that, and that is by using the database function. And for the database function, you see, we need a couple more fields, but what you can do is that there is a database function where you say we want an average, so the average is database average. We take the entire table, and you see there is even a bit more room because we might be adding to this table later on. And then I want the data from the column them, and I have this here, I19 to K20, the red area over there, and those are my criteria. Now, how does it work? It will take the whole table, it will check the column them as a return information, but then here we basically have, well, I took 6 fields here, but the ones it uses are actually only these 2. It will check the top row for columns, column names. So in this case, supplier is the name of a column here, and then underneath is the criteria. So here we want supplier to be A. Now, that we use for several of the formula here. And the most important one, because this you can still do with average if. If you know that function, average if will do basically the same. But the standard deviation does not have a standard deviation if version in Excel. We do have a database standard deviation. And here we use the same setup of the formula. So again, we have this table. This, in this case, because it is a paired t-test and we want to look at the standard deviation of the difference, we take the column difference. And again, I have the same set of criteria here. And what it then says is, okay, I will do the standard deviation of this column, but only for supplier A. And that's exactly what we have been looking at. And when we change this to supplier B, you will see it takes only the samples that we have for supplier B. So that's a very neat way to organize and get a standard deviation. Now, we also have database count to get the number of samples that we have. The standard error, as we learned, is the standard deviation divided by the square root of the sample size. Well, we have that information now. We get a t-value. Here, with the t-value, there is something special, and that is that in the distribution, theoretically, you can have negative and positive values. This is no problem for the student distribution. It is a problem for Excel. So here we just have to do the absolute of the difference divided by the standard error because of Excel, basically. It has no effect on the statistics involved. And then we have our two-tailed t-distribution. And here what we do is there is this formula t-distribution dot two-tailed, and there is also a one-tail. And then we have to put here the number that we have, so our t-value, and the degrees of freedom. And degrees of freedom is always the number of samples that you have minus 1. Now, if we move on to a third way of doing this, I think a more intuitive way for many people is to use pivot tables. And the very nice thing that a pivot table does is that it will give you only those values that belong to whatever filter you put in here. In this case, again, only supplier A. And if we do it with this built-in t-test function with its ranges, I mean, we have a table over here, so we can just filter out to include only A. It will probably remove the t-test thingy, but the difference being 74, if we filter to only include supplier A, this doesn't change. So the filtering of our table has no effect on these functions that use the entire table content. So when we have a pivot table, we can just filter. We can say, well, I would like to have B. And we get a different set of numbers. And then we take the average of this set. We take the average of the other set. There is a difference. We can do a t-test with the same thing. You have your two arrays aligned. And when you change your pivot table alignment, there's no problem. Those functions, they will include the rest that you put in. Now, there is one bit of a problem here, and that is that you will have to update your pivot tables manually as soon as you enter new data. It will not be automatically added to the pivot table. You need to refresh your data before doing that. But a good thing is that we can copy this whole set and we can also put another selection to the second part. This, by the way, is also very doable with the database functions. So if we have the database functions, we can do exactly the same. That is, we can, if we also copy our table of criterion, you can just get different views to get different results. You see, it does have to spill, it doesn't automatically update. There is a new function which has been already in Excel for well over a year, but it might not be on your computer because you do need an Office 365 version of your program for this. It will update into the desktop applications as well, but you will have to make sure you get the latest updates. So most people within my company at least do not have the filter function, and this is also one of the main reasons why I would be a bit cautious in using it for files that you need to spread and collaborate on with colleagues. But if you know that the people you work with do have this version of Excel available and can use this filter function, that is a wonderful way to work with. It's only in the top left cell. Here is a function to filter the weight control table, and then we want them and us, so the them is what's on the document, the us is what we measured, and I would like the supplier specifically to be equal to what is in cell A66, so that is A in this case. Here what we basically get is the same as the pivot table, but this automatically updates. So if we do add an extra sample, then here we see that it is automatically added. With a pivot table, we have to go and refresh the table. for it to be included in our data set. So that is a very nice difference. These filter functions automatically update. So far, it's basically the same as a pivot table. But now for the real trick when you have these filter functions, and that is that you can nest it. So instead of making the actual table, you can just tell Excel, you can use these same things. So you can use the them column with the supplier being A, and then the second set of our pairs is the us column with the supplier being A, and it puts these filter outputs that would normally spill in your other cells, it puts them as an array into the t-test function, and it all updates. So if we now change the filter, we see that everything changes quite easily. And what we can also do is if we copy this, it still works very, very nicely. So if you have the filter functions available at your workstation and also know that your colleagues will have it, wonderful way to use and to do this t-test, because then you can just use the t-test formula. You have your two arrays where you put in the filters and you choose whether it's a one or two tail, usually two tail for what we do, and the type. So as I said, is it paired or is it two populations that we need to compare? Now, another thing that we saw, and here the database functions get back a little bit of extra power, is that in functions B, or actually we should check it here, so our B supplier has a huge difference here, very significant also, but then when we check our individual data, we can say, well, sample 19 plus 11 kilograms on a 40 kilogram bag, probably one of us really didn't measure correctly. So let's exclude this as an outlier, and with the database functions this is actually relatively easy, because what we will do is, let's do it with supplier B, we type in that we want the difference column to be less than 6, for instance, and it updates and it makes sure that it takes only those differences into account that are 5 or less than 6. So you see that you can add criteria to what you do with your database function. That makes it very strong. With the filter option, this is a lot more difficult. With pivot tables, of course, we can do this, and we can do it by putting an extra filter in there. But here you see there is some difference between how you do this with Windows and Mac, and there is some manual stuff to do, but in the end we can do it. The database function really makes this process very, very easy. So I hope you liked this video about doing a t-test in Excel in a couple of different ways. Maybe this for you is also the first time that you see these database functions being used. For me, I don't use them that often, but this is one of those things. The standard deviation is in a database function, and this is a very difficult thing to calculate manually or with sum and if functions, almost impossible. And of course, I hope we get those filter, sort, let functions that have been in Excel for about a year or so now more into the standard programming so that we can really use them. Anyway, if you liked the video, hit the like button, subscribe to my channel if you haven't done so already, and let me know down in the comments what would you also like me to explain. Are there other things within the statistics of Six Sigma or on another topic that you're struggling with that you would like to have some more background? Drop me a comment, I'll be happy to look it up and share the things that I've learned throughout the years. And for now, I wish you the best of luck on your Six Sigma journey, and as always, enjoy that journey.